In this video, we're going to be taking a look at multi-threaded GPT-4 autocoder and self-improver. With this one, you can start as many improvement processes as you like. As you see, we're going to start 1, 2, 3 improvement processes. Let's actually go with 4. And you define what do you want to improve in each process. You can enter an idea or leave it blank, and it will come up with an idea and code it and improve it for as many iterations as you specify here. Let's just go with 3. But in this case, we want to improve from an existing file. When we click here, it's going to display our files. We're going to select the test.py file. These files are populated from a folder called Files to Improve. You have to have this in your working folder and put as many files here as you would like. And when you click this Improve from an existing file, you can select any file you like. We're just going to select the test.py. We're going to improve it for 3 iterations for process 2. Let's ask for a calculator. And let's write and improve it for 3 times. For process 3, we're going to leave it blank, so it's going to come up with an idea and code it as well for 3 iterations. For process 4, let's ask for a Python class for financial data calculations and write and improve it for 3 times. Now, pay attention to what happens to the experiments folder. As soon as we click generate code, 4 processes are initiated. So as we actually improve on these, the GPT-4 autocoder improves on them, we actually get to see the files written here. So this is the test.py file, was just a simple print statement, as you can see right here. So its first update, and we move this to the side, is actually a more elaborate version of the print statement. And as you see, it keeps adding and actually writing the improvements it's doing. The second process is a calculator, as you see, and this is its improved version. You can see the differences from the bird's eye view right here. As I go to the next one, it had added more stuff with the explanations of what has changed. In the second improved iteration, it's just adding more. Process number 3 was the one we left blank, so it came up with dictionary to store birthdays. So it's writing a script about dealing with birthdays, and it's updating it. As you see down here, it explains itself. Process number 4 was dealing with financial data, and it's creating a financial calculator, interest rate, future value, present value, number of payments, calculate present value, future value. So it's adding quite a lot of stuff. And in the third iteration, as you see, it is trying to improve. This is prompted to add new features, to add error catching, as you see, with try and except blocks, and also it tries to do debugging for you as well. So we're going to review the entire code. As you see, almost all of our improvements are complete. You can run as many improvements as you like. So this is great. We are using GPT 3.5 for speed purposes, but you can use GPT-4 as well. So let's begin now with the code review. We're going to be reviewing code for 2 files, the class for the GPT-4 autocoder self-improver, and then the script which runs the Streamlit interface while importing the parallel class from the GPT-4 autocoder from the main self-improve parallel class file, this one. Let's begin with the class itself. We are importing OpenAI OS concurrent features for multi-threading and You do have to need to have OpenAI pip installed. Then we are defining a class called GPT-4 autocoder self-improver. This just takes one attribute, which is the process input list. Because we are running multiple processes, we're going to have to ask ahead of time which inputs for each process that the user wants to initiate. We are using the static method, so we don't have to put self in front of every one of our methods or the attributes. We are defining a method called askGPT3, which is going to get question, which is going to come from the user input. We are getting a response from OpenAI chat completions. Here in this case using GPT 3.5 Turbo. Here's our system message, which says you are a helpful Python coding AI who will generate code and provide suggestions for Python projects. You can read it. And we are entering the user's question that is inputted through the interface right here. And then we try to get a generated text as a response in this fashion. And we just print it for information purposes in the terminal. And we try to find the last triple ticks. This is why we're using rfind. And then we are getting everything until that. This is our index slicing. Then we try to return it also after the first Python that is mentioned, because since we are writing Python code, the response object includes Python ahead of the code. So we're doing 2 things, finding the last triple backtick in the first Python and trying to get everything in the middle of it. Okay. But this doesn't always occur. Sometimes the response just doesn't work with this parsing method. So if we get an index error because we are indexing it right here, right? In that case, we're going to try up to 3 times to get this and try to do the parsing. And if we fail 3 times, we're going to print an error message. Here we have another method called getProjectIdea. We're going to get the user input from the user interface. And if the user input is empty, then we prompt GPT to come up with an idea, then provide a sample code, write the code in one code block between triple backticks, comment the code. If the user input is given, then we say generate code for the Python project for whatever the user input is. Then we have another static method to check to create experiments folder right here. If this folder doesn't exist, it creates it. Another method for saving the generated code. This receives code, the process folder, file name, and a boolean for use original file name as arguments, and it creates the process folder right here. It checks, and if the file name is done, then starts with the file number 1 and goes through the process of creating these process folders. And then it tries to find the file name associations as well. And we are using the regex for that because it checks for the file that if the file already exists, then it tries to number it differently, and we are returning error if we don't find the necessary files. The next method is getProcessInputs. This collects all the inputs as we have seen ahead of time for all the processes. Before we dive into this method, I just want to say that all this code will be available for my Patreon supporters. The link will be in the description. So getProcessInputs gets a process number and prints collecting inputs for process number. So if in our example earlier, we have specified 4 processes, so we are inputting the processes as for the first one and the second one, third, and the fourth. We check for whether self-improve is true. This is for improving from a file. Selected file, none, we initiate it to none. And whatever file we choose, right, from our files to improve folder. User input is none, but we're going to receive that. And self-improve input, this actually gets the input and asks if you want to improve an existing file. So this just asks the question. And we're not using this in the Streamlit interface, but if you want to run it in your terminal, then you would use this. And if we say if this self-improve is yes, then we set self-improve to true. Then we actually search for all the files in the files to improve folder, and it's assign it to files. Then if there are no files, then we print this. Otherwise, we say the list of files is such and so. This is, of course, again, to work in the terminal. We're going to take a look at the Streamlit interface as well. And then the selected file is choose a file number for the process. After it gives us a list, it allows us to choose. Otherwise, the user input, if the self-improvement process isn't been selected to work from a file, then we ask the user to enter an idea or leave it empty for a random suggestion. And then we ask for how many iterations of improvement would the user like to enter, like this. And then we simply return the user inputs, which is the user input, self-improve, selected file, and number of improvements. Then we have a create process folder, which takes in the process number. Then it actually creates the folders. And then we have a run process, which it takes in the process number and the process inputs. And it says starting process, whichever process it is working on, process folder. It uses the create process folder from the class, the method from the class. Then we use simply the main method, which we're about to get to, and input the process inputs plus the process folder. This brings us to the main method, which takes in process inputs and the process folder. It prints a nice little message. Then we assign the user input self-improve selected file and number of improvements, which we have received from the user. Initialize the file number variable here. And if we're not doing self-improvement, then we actually get the question by using the getProjectIdea method. And we get the response by calling the GPT-4 method from our class. And we get the file number from save generated code. And we print the generated code has been saved to the appropriate file. And then we change the file name prefix to the appropriate number. And I believe this is redundant. We could just comment this out, but I'll leave it there. And because we have generated a code right here in our response, right, from the input, then we attempt for the number of improvements, and we change the question to the code to be improved is, and we enter whatever was generated. And we say improve the following Python code. Implement new ideas if necessary, including error catching and bug fixing. okay, and some other instructions. Then we continue we do the same thing. We get a response with this new question, update the file name, save the generated code, process the folders, and then we save the files. And then this process repeats for as many times as you have selected for iterations of improvement. However, if the user has selected for self-improvement, which allows you to select from files, right, code from files under the files to improve directory, then we open those files. And I was just printing the first 100 characters just to be sure, just for information purposes. And we use the original file name without the extension as the prefix. So then we again do for however many attempts that we are going to use, we input the code that is read from the file right here. We are reading it. We are reading the file as a response object, and we are inputting it into our prompt, and we instruct it to do the same improvements and error catching and bug fixing. Then essentially the rest of the process is the same as what we've talked about here. Then we have the main concurrent. So this was our main method. This just runs it for one process, as many iterations for as many iterations for one process. But the main concurrent is now going to allow us to initiate multiple processes in parallel. So we say in this method, while true, we say the number of processes is how many processes we want to start. In this case, we are actually receiving the input from the Streamlit app. But again, this code can be manipulated, can be run on its own in the terminal. I just wanted to mention that. Maybe we can run it and I can show you real quick. Anyway, we assign the processes, and then we get the process input list from the terminal inputs, and then we just initiate the process for get processing inputs, and then we append those inputs to the process input list. And with concurrent features, process pool executor as executor, we assign the process numbers, and then we map over those, and we execute them one by one, and when they're done, we print all processes are complete. Class, as you see, you can interact with it in the terminal. How many processes do you want to start? Let's say 2, and then it asks you for process 1. Do you want to improve an existing file? If you say yes, then it will list you the files, and we can select test.py as we did before. Then it asks how many iterations of improvements would you like for process 1? We can say 1. And then now it's asking to collect inputs for process 2. The same questionnaire repeats. And once you're actually done with this, then the same actions, the same processes start, just as we've started from the Streamlit user interface. I'm not going to go ahead and do it, but you can actually run this in your terminal. But I have created a nice user interface for it. So let's start talking about that now. We are importing Streamlit. You need to have Streamlit pip installed. And then we are importing our class. We are importing our class from the appropriate file, main self-import parallel class.py. We are importing OS, and again, we are importing the thread pool executor. This is not necessary. And then we have a run process, which takes an I for process number, process inputs, and process updates, and creates the process folders using the create process folder method from our class. And we run the main function using the process inputs and process folder, and we return I process folder and the process inputs. Now this update code display was for my attempt to actually display the code on the user interface as well, but I couldn't get it to work. I'm gonna leave the code here. Maybe one of the viewers can want to take a stab at it and get it working. Anyway, with st.title, we say what this is about: GPT-4 autocoder and self-improver, and then we get number of processes with a slider. If you remember, this was our slider. And then we are assigning a process input lists, and we are doing a for loop for the number of processes, and then we are processing these inputs. The user input is a text input box. Self-improve is a checkbox. Selected file is none, but it's going to give us an option to be able to select. Number of improvements is whatever we input into the slider. This is separate than processes. Processes are how many total processes you want to start, and number of improvements is how many iterations of improvement you would like for each process. So if you have a process input self-improve, then we look at all the files and files to improve, and we actually display them in a select box fashion, as we had seen. And we process the inputs by appending the input list by appending the process inputs. Then we're creating a button called generate code. And if process results in not in session state, then we create it for all the codes in range of the number of processes. We create a key, we initiate a dictionary. The session state in Streamlit is important because if you've ever played around with Streamlit renders, reruns the entire script from start to finish every time you make an action on the user interface. So session state It's a great way of storing information which you want to persist over many iterations of interactions with your Streamlit user interface. So then we say, after obviously we're still in the button click action, with thread pool executor as executor, we get the process updates, such as this. Process the results with the same executor.map, but this is part of the line from before. The next lines of code was an attempt to actually display the generated code, but like I said, I wasn't able to get it to work on the Streamlit interface, but all the files are saved under experiments under the appropriate process folder. Again, if you'd like to take a stab at it, let me know in the comments or in the Discord channel. I'll put the Discord link in the description if you want to talk more about it. I think the elif here is a redundant process, again, to display the code on the interface. So it's a bit of a spaghetti code, but I'm just leaving all the code here so you can get ideas and maybe try to improve it. But essentially, so this is how it works. If you wanted to run this, we'll initiate a terminal, okay, and make sure to start a command prompt by clicking this arrow and clicking on command prompt. Make sure you're in your right environment and you have Streamlit and OpenAI pip installed already. And then you just type in Streamlit and then run, and the name of your file, I just copied it like that. And when you press enter and execute it, it's going to start your web app up. And you can also copy the URL from here. As you can see, you can set up to 10 processes. You can actually change this to any number you like. This is just a limiter, and you can start up to 10 iterations. Again, you can change this. Let's take a look. Here, for example, for the slider, we're limited it to 10, but we could just say 100. And if we save this, it should automatically upgrade. We rerun. See, now we can start up to 100 processes. I just left it limited because these do cost tokens, especially with GPT-4. Be careful. You don't want to run a huge bill. Again, like I said, I'll have these code available for download for my Patreon supporters. I hope you enjoy this, and take care. I'll see you in the next